howdy from Texas A&M, and welcome and appreciate the opportunity to be here with this webinar. Looks like an outstanding event. Before I start, give you a few disclosures. I've been doing research on creatine for over 30 years, and some of that has involved industry-funded projects. We currently are doing a study on elderly and cognition funded by the Wood Next Foundation, and I serve as chair of the Creatine For Health Scientific Advisory Board, which is trying to raise awareness about the health aspects of creatine, which we'll talk a lot about today. So without further ado, let me get into, and before we start, if you know anything about the landscape of sport nutrition is evolving into active nutrition and nutrition for maintaining health and performance and cognition as you age. And if you look at the history here, creatine's really leading this charge as a nutrient that was once thought to be for sports and performance and training, now has evolved into a health substance. And you can see this is now creatine's in all type of products. If you look at the market, it's expanded to active nutrition, general health, aging in particular, and then nutrition for disease management under certain clinical conditions where creatine's been involved. And over the last couple of years, since we really started this increased awareness about creatine and health, sales worldwide have doubled to the point where Allschem, the leading manufacturer of creatine in Germany, had to start a second plant. And there's actually a worldwide shortage on creatine availability that people are starting to put it into a lot more type of supplements for general health, and really looking at things like recovery and pre-workout supplements and things to just promote general health as you age. And so we're going to talk about today what we know about creatine as a sports supplement, but I really want to focus in on the role on how creatine is expanded into the health market. And so really, how is this transition from a sports supplement to a health-related supplement that now has applications from the third trimester pregnancy all the way to the elderly individual that can benefit from creatine in certain health and disease conditions. So a little bit of background, you already know, anybody knows sport nutrition knows creatine is one of the most popular nutritional dietary supplements out there. It has extensive body of literature. There are well over 1,500 clinical trials have been conducted, short-term, long-term, many studies on health and safety. And the data shows that if you take extra creatine in your diet, you will load more creatine in the muscle. And this will allow for more phosphocreatine to be available for energy, for high-intensity exercise and performance. And if you take creatine, you get benefits like greater recovery and more glycogen storage and better thermoregulation and some rehabilitative effects. And there's even evidence to suggest that there's a lessening of severity of things like concussion or traumatic brain injury, which we'll touch into a number of areas. So that's just the general background. And so if you look at creatine, you can get it from your diet, or you can get it from the natural synthesis capabilities that the body has. About half of your creatine that you have for daily needs is synthesized through a creatine pathway that involves the combination of L-arginine, ornithine, and glycine to form guanosine acid. And that then is methylated to form creatine, and then that creatine is available in the cell for phosphocreatine for energy. And so this can be done not only in muscle, but kidney, liver, pancreas, and even the brain. There are different transporters and different creatine kinases that are all involved in the transportation, utilization of creatine, and synthesizing phosphocreatine and resynthesizing ATP that are being sent by the body to increase the need. And so that's the basic synthesis. And so if you take a person, 95% of most creatine stored in the muscle. That's where a lot of the initial studies looked at performance and muscular adaptations. About 2/3 of that is stored as phosphocreatine, and the other third is free creatine. It's available to be bound to phosphates and form phosphocreatine and recycled for the ATP-PC system. As I mentioned, you get about half of your daily need for creatine from the diet, depending on what type of diet that you have. And that's generally recommended to be at least a gram, maybe 2 grams per day from your diet to offset what the body can synthesize. And so most of that comes from things like meat and fish. And we'll see in a minute about the content. And so when you consume a meal that contains creatine, for example, in orange here is 2 grams of creatine consumed with meat. You typically get an increase in creatine in the blood that is sustained for 3 or 4 hours, and that's enough to be able to increase absorption of creatine through creatine transporters into tissues that need the creatine, and then the creatine is available to form with phosphates to form phosphocreatine. If you compare that to putting 2 grams of creatine monohydrate in fluid, you get a little bit higher peak from creatine monohydrate, but you still see this effect for about an hour or so peaks, and about 2, 3 hours later, it's sustained. This is the same whether you have it in solution or in candy or in gels. There are often different type of supplements. Gummy forms of creatine now are popular, for example. And the 5-gram dosage comes from initial studies by Roger Harris that showed that the optimal level to peak in the blood to really push creatine through transporters into tissue is about 5 grams. And if you can see, 5 grams will get about an increase to 800 micromolars per liter compared to food, which is about 200 to 300. And that will stay elevated for about 4 hours. Thus, we recommend 4 doses of 5 grams a day to maximize absorption into muscle. And those studies have been done to show that. So that's an impact. Now, there's lots of information about creatine in different forms. If you look at Instagram, there's one now on creatine HCl that's being pushed. It's supposed to be better than creatine monohydrate and have no side effects. And it's a bunch of garbage. Okay, so here's what you need to know. Creatine can convert to creatinine. It's very stable in creatine monohydrate form. And if you look at the diagram here, if you put creatine monohydrate in water and had a neutral pH, it'll take about 3 to 4 days, and you might see a 5 to 10, 20% drop off in the creatine amount in that fluid based on the conversion to creatinine. So a lot of people who are trying to get market share will say, oh, it doesn't convert to creatinine. Well, here's the problem. When you consume creatine monohydrate in the body, it gets to the stomach, and the hydrochloric acid stomach and the pH in the stomach is well below 2.5. Once you're below 2.5 pH, creatine does not convert to creatinine at all. The same thing when you get a pH above 12. And so when you consume creatine monohydrate powder, it's nearly 100% bioavailable because it does not degrade into creatinine. It is either absorbed into tissue that needs it or is excreted in the urine. In fact, we do studies where we can actually measure creatine retention based on measuring how much creatine went in and how much is urinated out. And the difference is basically what the body retained. So with that understanding, we know that if you take 3 to 4 doses a day of about 5 grams per dose, and you load what we talk about loading, that this will increase creatine about 20 to 40% within 5 to 7 days. And there's some that have suggested that 0.3 grams per kg is probably a better way to gauge this depending on different sizes. And there's some also, if you take 28 days of 3 to 5 grams of creatine, you'll get about 80% retention after a whole month. And so that's a kind of a low dose protocol. And so usually we'll recommend loading and maintaining and versus the low dose, although health proponents suggest you should probably take 3 grams per day throughout. We'll talk about. And it takes about 4 to 6 weeks after taking creatine and the stores of creatine elevated for them to dissipate back down to normal. So it takes time after you've loaded to really see a drop in creatine. Now, if you took a person on a normal meat-eating type of diet, they have about a 100 millimole per kg dry weight muscle concentration of creatine. If you creatine load 20 grams a day for 5 to 7 days, you'll add about 20 to 40% creatine to that pool, That means you have more phosphocreatine in the muscle, more energy for explosive activities. And if you take it with carbohydrate or carbohydrate and protein, you'll get even a greater retention. We've often talked about this upper limit of 160 in the literature. And on average, that's about right. But there are individuals that can store 200, 220 millimoles per kgb dry weight. So we're learning more that certain tissues might have higher levels and withstand more uptake of creatine. And so generally, if you consume more creatine in your diet and load, you tend to have a 20 to 40% increase. Note that in vegetarians, who typically don't get as much meat and fish in the diet that contains high levels of creatine. And in the elderly, because of digestion issues and maybe not consuming as much protein, meats and fishes, type of foods, they typically have a lower level of creatine. And there's actually some data showing that vegetarians respond better to creatine supplementation, and probably more important for them and elderly to get the stores back up to normal. So this is kind of like glycogen loading. If I have a long race and I start preparing to go for a marathon race or a triathlon, and I increase my carbohydrate intake before the competition, I load the muscle up as much glycogen as possible and liver it with glycogen, I will last longer. The same philosophy is with creatine loading, is if I load the muscle up with more phosphocreatine, with creatine supplementation, I can therefore have more energy available to do sprints, recover from sprint to sprint, and result in a better quality of training. So that's the basic philosophy. Now, a couple years ago, we did an update on our bioavailability paper, and there's only one creatine form, creatine monohydrate, that has been shown consistently in the literature. 95% of all studies we've done on creatine monohydrate. And this is the only form of creatine that has worldwide approval to be sold as a dietary supplement. And there are a few things out there that have a little bit of evidence to show some efficacy, but notice it takes more creatine of those sources to equal the same dosage of creatine monohydrate. So we typically think these are less effective because it would take more dosage to equal the impact of creatine monohydrate. And none of these studies show greater uptake, even though you hear a lot of media and advertising saying these are better. None of these have been shown to have any beneficial effect, and none of these shown to have better training adaptation effects. So creatine monohydrate is still the king of the mountain. The other ones seem to have a little bit of effect, and there's a whole bunch of things that studies simply show do not work. So this is generally recognized as safe. It's approved by FDA. It's approved to even put into food additives, not only in human food, but it's also quantitative acetic acids put into feed and other things for animals, and to try to increase creatine and availability for them. So creatine monohydrate is the best one. So what do we do? What do we know? In 17, we did our second position stand on creatine supplementation, and here's the take home. It's the most effective ergogenic aid to increase strength, power, high intensity exercise performance, and training adaptations for power type athletes. It's not only safe, but has been used in large content in clinical populations in dosages up to 30 grams per day for 5 years. Our initial studies actually were 15, then 20, then 25 grams per day for up to 3 months in athletes to try to see if there is a benefit. And so there's lots of safety data. Next thing, if you are a younger athlete, some of the initial studies on safety of creatine are actually in clinical populations in kids. And when you look at the relative intake, they are relatively high. So our position is, as long as the adolescent athlete knows what creatine is eating a good diet, training well, and doing other things properly, then creatine can be something to consider to improve their performance as well. And we'll give you some data to support that in a minute. So what else? Warnings about creatine, sometimes on labels, is generally for legal interest, has no data to support the need for. Right now, creatine monohydrate is the most extensively studied and best evidence to show clinical safety and efficacy. If you add carbohydrate and creatine, as I mentioned, you'll get a little bit better retention of creatine, and you may also get some greater advantage of glycogen loading effects from taking creatine as well as the carbohydrate. The best way to load and get creatine stores is to load with that 4 times 5 gram dosage per day, or zero point 0.3 grams per kg per day for 5 to 7 days. And then it takes about 3 to 5 grams thereafter to maintain, except if you're a large athlete. If you're a larger athlete, we actually have data in football players. The many of the average football players was about 100 kilos and up to 140 kilos. They need about 10 grams per day to be able to maintain their creatine store. So in larger athletes, we actually recommend a little bit more. In clinical populations, which we're going to focus on, studies have shown really high intakes for a very long period of time, equivalent dosages of 21 to 57 grams, 56 grams per day in 70 kg individual equivalents, clinically for years without any side effects associated with that. And so we in 17 said we need to do more study on the health effects. And there was beginning to see some evidence in clinical populations of benefit. And so this prompted us a couple of years ago to launch a Creatine Health Disease Initiative with the support of ALSCHEM. And Jeff Stout and I sponsored a special issue on Creatine for Health and nutrients that then wrote a seminal paper that's been cited hundreds of times so far. And we talked about all the different roles of creatine in health and disease that have been studied, or at least been started to study or speculated and theorized that there may be benefit. And we'll show you some example. And we have a great website called creatineforhealth.com where you can see all the papers that published in this series, download the book that came with it, and also see all the presentations of the 2022 conference that was done, all available on YouTube, free. Take a look at it if you want to know about creatine and health. So why is creatine important for health? Well, we're going to look at several applications. First, the metabolic basis for creatine health really deals with all the metabolic roles that creatine plays in the body. This diagram from one of our papers in the special issue has little green lights or sparkles. And everywhere you see green is everywhere that creatine plays an important role in metabolic activity and things like mitochondrial function and nerve transmission and energy capabilities and shuttling phosphated and glycolytic intermediates, muscle protein processes and contraction, neural pumping. And so when there are deficiencies or mitochondrial dysfunction, they alter the metabolic activity. And this is where creatine plays an important role, as we'll see in a minute. So let's take a look at this. We'll go from a spectrum of infants all the way to elderly, and then some disease, and then we'll talk about the dietary influence of creatine on health. And so the first one we'll talk about is work from Australia, from Stacey Eller's lab, and they've been doing lots of studies on creatine in pregnancy. Mothers who are pregnant have lower creatine stores because the baby is actually pulling creatine out to develop and have normal development and maturation during the pregnancy, particularly during the third trimester. And when there's asphyxia that occurs during childbirth, like a cord wrapped around the neck of the baby, the blue baby, they found in animals that if they creatine-loaded animals before they had those type of asphyxia-related births in the animals, that the survival rate was markedly improved and the amount of brain damage was markedly reduced by having these animals fed. And so this got them to take a look at lots of what happens to creatine levels in tissues, in animals and humans as people go through maturation. And we know now that creatine is very involved in the reproductive health of women, everything from the endometrium and follicular fluid, placenta has a high concentration of creatine in it. And so that during metabolism and pregnancy, there's a greater dietary need of creatine. So we actually are recommending that third trimester women add creatine to their diet to be able to provide this energy and availability of creatine needed and to reduce the risks associated with asphyxia during childbirth. Interesting. And there's a bunch of new studies coming out on this. This is a new area of creatine application. Next, we've talked about creatine in athletes, and usually we think of college age or older adolescents, high school athletes. But there's been a lot of use of creatine in younger children. And we know that kids who have neuromuscular diseases or creatine synthesis deficiencies, that they benefit from having extra creatine in the diet. There's actually some data will show that indicates that kids with low creatine in their diet have a number of health outcomes that are not beneficial. We'll see that a little bit later. So things like cancer and depression, brain injuries, spinal cord injuries, orthopedic injuries, bed rest, all have had application, particularly when there's muscle myopathies or muscular dystrophies in kids. And the dosage of these adolescents and children are typically well above loading doses for long periods of time. And so this is some of the interest here. And so we all know of the athletes, even in high school athletes, they could see benefit. But in children, there's been a lot of interest in use of creatine clinically. Then we know about the performance effects. And this paper we did breaks down the types of performances that creatine has been reported to benefit. Strength and power is what we typically think of creatine, but there's also some prolonged high intensity exercise, endurance exercise, agility, sprint performance, jump. All these type of competitive athletes have been studied and shown benefit with creatine. And there's even data showing faster recovery, less muscle trauma, less muscle soreness, better recovery when you have creatine. So from a performance perspective, there's lots of data supporting efficacy, and Ben Wax did a nice job summarizing this. The really hot areas now are women's health. We now know that as women typically don't synthesize as much creatine, in part because of body mass and muscle mass differences, et cetera. And so they tend to be a little bit lower on creatine content than male counterparts. We know that as you go through the menstrual cycle, there are changes to creatine kinase, PCR, creatine monohydrate might affect and improve that and lessen the effects on menses and pregnancy, postpartum, menopause. All these things are being studied, and Abby Smith-Ryan's leading that charge at North Carolina. We know that premenopausal, perimenopause, postmenopause, there may be some benefit on things like bone and preventing fat accumulation and helping keep lean muscle mass. There's even data in women on cognition that we'll talk a little bit more about in a second. So the whole aspect on women's health, Abby's now doing studies where they're looking at providing creatine at different phases during the menstrual cycle to see if they can optimize not only training, but health outcomes. Another big area is creatine and aging. As you get older, you lose muscle, you gain fat, you have less strength, and you typically lose bone and lots of cognitive function declines. And so we now know that when you give creatine to older individuals, especially when it's combined with an exercise program that involves resistance training, you get stronger individuals, you get more muscle mass, you tend to see a little bit more fat loss. Bone mass has actually been increased in studies up to 2 years. Performance is improved, and there's even data on cognition that's improved in elderly. And so populations that are osteosarcopenic, sarcopenic obesity, frail, cachexia are now being looked at as a population where it may benefit from not only protein intake and resistance training, but also creatine supplementation in addition to that. And Darren Cando's group has done a wonderful job looking at that. Then there's a whole area of research now looking at creatine in the brain. And this research started with observations that creatine is related to lack of creatine in the diet is related to depression, and that if you give creatine, you actually can increase brain creatine content and phosphocreatine content, and this is associated with better cognition. And so there's also evidence that if you get injury to the brain, if you have creatine in the brain at a higher concentration in animals where they cause concussions or spinal cord injury or stroke or some type of brain damage, that the individual or the animal that is fed creatine in their diet doesn't have as much severity of trauma due to the insult. And so there's a lot of interest now how we can increase not only your muscle creatine, but optimize creatine uptake in the brain and whether that affects function. And there's a number of studies show that if you give creatine loading in elderly, their cognitive functions improve. Your creatine can increase your brain. If you are sleep deprived, it may affect your ability to think with creatine. And we're doing lots of studies now and interest of how creatine can reduce the severity of concussion and traumatic brain injury, and even treatment of CTE in athletes and military. And we're actually working to try to get some large scale studies going with that. And so a whole host of things on brain and creatine function. What else? There are studies in heart disease that if you provide creatine, the heart can function better, contract more stronger, and have less arrhythmias. And so they have actually done studies where they've induced heart disease and stroke and heart attacks. And they basically found in heart failure models that providing creatine or creatine feeding helps improve the heart's ability to withstand ischemic events. And so maybe this could be something for heart patients to take to prevent or reduce the potential of problems associated with angina and other type of events. So this is another area of real interest now with creatine. There's actually data now in vascular health that the endothelial cells are dependent on creatine, and the ability to have creatine can affect the nitric oxide production and the ability for the vascular bed to respond to pressure and oxidative stress and other stressors that affect it. And so there's some thought that maybe creatine can help with the vascular smooth muscle compliance. And there's also evidence in a few studies showing lower cholesterol. And so there's some interest in the general heart benefits and vascular benefits from creatine supplementation. Say, okay, well, those are, wow, I had no idea that creatine did all those health things. What else? They've actually now done studies in certain diseases to see if creatine supplementation can help mediate or manage the disease or progression disease or reduce the need for medications. So, for example, kids that are born with creatine transport deficiencies or creatine synthesis deficiencies, they don't have those enzymes to produce creatine as well, or they can't take the creatine up in the cell, that they have been given very large doses, 0.3 to 0.8 grams per kg per day, to try to help reduce this. And when they identify infants that have creatine synthesis deficiencies, they typically have very poor mental and physical development in the first few years of life. It's noticed. They identify the brain deficiency, in particular the low levels in the brain. They start treating these kids, and their motor development is much greater and much more on a normal path once they identify this. So there's a lot of interest initially, and their studies have gone on for years where they've given these kids with certain deficiencies creatine to try to help prevent and improve function. We did a paper on mitochondrial dysfunction. When you have things that reduce the mitochondria's ability to function, there's a greater need to produce energy anaerobically. And when you handle ischemic events, if you have more phosphocreatine in the cell, it allows the cell to be able to handle those ischemic events with less damage. And so there's a whole host of mitochondrial deficiencies that are typically associated with poor creatine content. And by reversing that, we see some benefits in these type of populations to improve mitochondrial activity and function. There's been a lot of interest in, well, if creatine helps training and strength and muscle as you do conditioning, what happens if you get injured? Does it facilitate a faster recovery? And generally, the studies show that if it's a muscle-based injury, it seems to allow for greater recovery from exercise spinal cord injury, arthritic diseases, and even muscular dystrophies. The evidence is pretty strong that creatine can benefit those type of populations. In the diagram, you can see which ones these are. And then possibly affect, I mean, it's a little bit more equivocal. These are muscle and some nerve intervention type things. There are studies showing injury, immobilization, less atrophy, for example. COPD patients have improved lung function. A number of different types of clinical conditions may have an effect, and it's less likely to affect, probably not affect, in the damage to nerve type of diseases like ALS or multiple sclerosis or Parkinson's. But these studies have been looked at for the role of creatine. What else? If you're diabetic and do exercise that includes resistance training, you have a greater ability to manage glucose better. And the diagram kind of shows you that it improves insulin sensitivity, it improves the ability to, through AMK, to get GLUT4 and be able to take up glucose in the cell. And so you're less dependent on things like insulin or glucophage or things, medicines that may help you manage your glucose. So the initial studies show some promise in people with diabetes who are doing exercise. There's some fascinating data out of Kristen Dresser's lab at Creighton showing an immune response that in some autoimmune deficiencies, creatine is a major source of energy, phosphocreatine, to help this immune cell handle immune challenges. And so these changes seem to improve immunity in certain populations. And part of that is because it takes away the inflammatory process that's associated with some of these diseases and therefore has some potential effects, not only in autoimmune diseases, but even some infectious disease. In fact, there's data now in cancer that from Lily Yang's lab in UCLA and others that show there are certain cancers that creatine, a lack of creatine, makes it easier for the tumor to grow. And by providing creatine, it actually retards or slows down tumor growth in certain types of cancer. So there's a whole interest in whether creatine availability and phosphocreatine can help offset some of these potential cancer and tumor growth and help manage in certain types of cancer. So very interesting type of work there. There's even studies in inflammatory bowel disease. Creatine is a player involved in the uptake of nutrients in the intestinal epithelia. And because of that, it affects your ability to absorb nutrients effectively. And there's some evidence that irritable bowel syndrome, for example, is related to a lack of creatine and ability to manage and process these nutrients as they're trying to be absorbed. And there are studies underway that are trying to look at, is creatine a way to prevent or improve outcomes? And there's a couple studies initially that are suggesting some potential benefit on inflammatory bowel disease. Wow. Some of the really cool stuff is that there were some studies out of Utah with Perry Renshaw that showed that depressed individuals that were suicidal and non-responsive to medications seemed to have low creatine availability. And then they did a study where they looked at people with depression seemed to have lower creatine stores. And therefore, they postulated that if you provided creatine, you can then reduce depression. And they actually have some studies where they combine creatine with acetylcholine and fish oil and show a lessening effect of depression, a lower propensity or interest in things like suicide. Fascinating area on brain effects. The last one I'll mention is post-viral fatigue and long COVID. And this is some studies out of Serbia with Serge Osijic, and they found that people who have chronic fatigue typically have symptoms that creatine might be able to benefit. And there's actually been some studies now that show that people with long COVID have lower creatine content in the brain. And when they give creatine to people with long COVID, that it seems to ameliorate or alleviate some of the clinical signs of long COVID. And this was 8 grams of creatine per day for 8 weeks with or without glucose. And it seemed to improve not only their perception of long COVID side effects, but statistically improved. But there's a number of things that had strong effect size that also suggest some things that are typically associated with long COVID may be better managed with creatine. Interesting. All right, so how do we wrap this up? Since our last international conference in 22 and seeing that study by Renshaw looking at the health implications of dietary availability of creatine, we talked about the need to do some of these studies. Let's look at NHANES databases. So here's some. Serge Osijek's done several of these. And the first one was they found that kids who had lower creatine in their diet had less gain in height, stature, less muscle, or less weight, and a lower BMI, suggesting that lack of availability of creatine may affect normal maturation. They then said, well, let's look at body composition of kids. And they found that kids with lower creatine content in their diet typically had less muscle mass, greater fat concentration, and less bone mineral content than kids who were getting normal amounts of creatine in a diet. And they defined this generally at least 1 gram per kg per day. They then said, well, let's take a look at women. And they did a large study and found that women with higher or recommended amounts of creatine in their diet had lower risks of irregular menstrual cycle, irregular periods, obstetric conditions, and pelvic pathologies. So there's a definite women's health impact on lower creatine versus higher creatine in the diet. They then said, well, let's look at older people. And they did a large database again, looking at older individuals, and found that people who are older, above 60, had lower creatine in the diet, had negative correlations on cognitive function, meaning that the more creatine you had in your diet, the better your cognitive function as you were older, above 60. They then did studies where they did creatine and looked at older men and women and looked at general health, and they found that people with low creatine intake in the diet had a 2.6 times higher risk to angina pectoris, had a 2.6 times higher risk of liver conditions compared to those who had normal creatine. So there seems to be some effect on chronic disease as well. What else has been done? There's studies showing that if you have people who have higher creatine content, does not have any association with kidney abnormalities, which is some of the thought on high protein diets maybe. That may be detrimental. Well, creatine doesn't seem to have any adverse effect there. There have been studies showing that if you have a higher creatine intake, there was no liver problems for liver fibrosis, cirrhosis, et cetera, compared to those who are lower. And they found, interestingly, that people with higher creatine content had less or higher neurofilament light chain, which is a neuronal damage type marker, and basically suggesting some higher creatine dietary effect on reducing damage to nerves as you age. Interesting. What else? There's a last study we mentioned is average intake of creatine was lower in kids and infants than expected. Okay. And so it seems to be going down, maybe because of our diets are focusing more on plant-based foods and less on meat type of foods that contain more creatine. But even though there's benefits of creatine, there seems to be a downward trend of creatine in the diet, which may mean supplementation may be more important. The same thing occurred in older individuals, that people who are older, typically in adults, 0.52 grams per day. The recommended dose is at least 1 gram in your diet to augment your synthesis capabilities. And there's even data suggesting that pregnant women have lower than optimal creatine intake. So, wow, how do you summarize this? Got creatine? Is creatine in your diet? Is there enough creatine in your diet? And so here's the summary. The benefits of creatine go well beyond what we thought about performance and muscle and training adaptations, lifting more weights, and things that we did our initial studies on anaerobic power and strength. There are a lot more evidence that there's therapeutic benefits throughout the lifespan. and in clinical populations where creatine, phosphocreatine may play a role in the disease management or pathology. Therefore, we recommend that everybody get at least 2 to 3 grams of creatine in their diet. Now, if you don't like to eat lots of meat, that means having a little bit of supplemental creatine. 1 little teaspoon is about 5 grams. It's very inexpensive, but there seems to be a lot of health benefits as you age. Some high-risk disease populations may need more. And for brain, for example, our current study on brain and cognition in older, we're actually giving 10 grams a day, 2 times 5 grams for 12 weeks to see if we can get a higher brain content and also some cognition effects from that. And there's a lot of opportunity research in health as well as how creatine can be applied and implemented for just general population benefit over time. So, the last thing I'll mention, our next creatine conference is this spring in Munich. It'll be available in person as well as online, like we did last time. It will have major themes around impact of creatine on aging, women's health, disease management, metabolism, cognition, and exercise, sport, and safety. We'll have abstracts. We're going to have presentations. There'll be awards for students. If you're interested, take a look at that. Go to creatineforhealth.com right here, and you'll learn more about that. But what I want to leave you with is creatine is more than a sports supplement. It's a health supplement. And what started with just looking at performance enhancement is a great example of how sport nutrition has now transited into general health and even potential for disease management and as adjunctive therapy to other type of clinical management of people with disease. So with that, I'm about out of time. So let me go ahead and finish it, open it up for questions.